we're going to do here is notice that machine learning A is now regarding regression, and machine learning B is talking about classification. Hopefully, yesterday's video we kind of noticed that, right? We did predictions, or we talked about a linear model. It was a review, but you notice that it was regression, and then we start to our response variable in B was categorical or categorical binding. So what we're going to do here is we're going to go ahead and bring back that small business. Okay, I know it's different from today's data science, but it's fine. That's fine. One of the things I didn't get to mention yesterday, if you want to learn anything about this in particular data set, you can go to this particular website. If you notice that it was already in the file and the solutions, I believe, that's fine. And so the small business data set, let's go ahead and run this. I'm going to suppress this because I don't like seeing that sort of message. I just don't. And there's ways not to do that, but that's advanced R. We don't have to worry about that. We know that we have this data frame. Great, fantastic. Okay, we have state, profit, administration, spend, all types of spend. Okay, so one of the things I'm just going to go ahead and just do, I'm going to remove those spaces from our data frame. Okay. All right, and so we'll do that. Okay, and we have that. It's great. So then the biggest thing I want to talk about is a concept. If you ever take any machine learning class outside of this, which I hope, right, is that you need to have a model, train the model, and then test it. Train and then test it. Train and then test. Okay? And there's a lot of ways of doing that. And what we're going to do is kind of like validating your ideas or validating your model using some data set. So what we're going to do is we're going to split our 50 observations into two. Our training data set and our testing data set. Training and testing data sets. Okay? And how we do this is it's not complicated, but it's just 3 lines of code. But it's nuanced. So what I'm going to do is I'm going to use this function. I'm going to say sm underscore, okay, and I'm going to pipe, and I'm going to take a sample. I'm going to split it up, okay, I'm going to say 75%. So why I use 75%? You would want to use a majority of your data to train, logically. I feel as though that kind of is intuitive, but you would want to, you don't want a small portion. You want to have a large portion and then try it on, test it on, the rest of your data. So I'm going to do 75. All right. And so what I'm going to do is I'm going to call this the same thing. Copy this. Go home. And then call this train. Okay. So that's that. So if I would run this, go to run. However, in R, it's ideal for us, if I were doing it on my computer and you do it on your computer, for us to, for us to get the same random sample. So when it says sample frac, it's getting a random sample, 75% of the 50 observations. So if I were to do it on my computer, you do it on your computer, ideally there's times when you would want to get the same result. I know that seems counterintuitive, but sometimes you want that. And so what I'm going to do is I'm going to call a function called setSeed. And so 2, 3, 4, 2, whatever. It could be any random number. And so if I do this, you do this, we'll get the same result on our computers. Okay. Oh, yeah, we should get the same result if we run it once. All right. The next thing is I want to get the test data frame. So I'm going to do test, or at least I'm going to do small, or SM business, supermarket business data frame. I'm going to pipe this. Now this is where it gets kind of weird. So it's something called an anti-join. If I were to teach a second data science class, we'll talk more about joins of data frames. But what this is doing is going to get every single element that's not in train but's in the SM data set. So I'm getting the rest of the 25% when I do this. So I do test underscore this, boom, right? So I'll get the remaining. So if I didn't have this line, this will be the 3 lines of code. Run it, bam. Okay, so if I didn't do 75, let's say I did 80, so it'll be, if I did that, you see it's 1040. All right, so you can at least believe me. All right, so then from there, what we're going to now do is do something kind of neat. So what we're going to now do is run a regression model. Run a regression model. And so I'm going to call this regression model A, and I'm going to call this train. Now what I'm going to do is I'm going to use a linear model profit to be predicted by the following variables. I'm going to choose bad ones because from yesterday's class, choose bad ones. So I'm going to tilde. I'm using advertisement spend and promotion spend. Why? I just want to choose bad ones intentionally. Okay, I'm going to do a model B tomorrow. All right, so when I use better ones to predict profit. Okay, data is equal to, let's say, we're going to use the training data set. We're going to use the training data set, okay? Boom. Okay, so when I do this, I now have my training data set model. So training summary. Okay, and so when I run this, we'll note that only advertisement spend is decent. It's a decent predictor. However, promotion spend is not good. Okay, we have R squared. Here we will be using adjusted R squared because we have two explanatory variables, and this is going to be the residual R squared. This is the RMSE, root mean squared error. Okay, as I mentioned last week and this week. All right, so from there, what we can now do is we can actually use this model to predict from our training. That's so cool. All 12 values we can use to predict. I get excited, sorry. And so let's go ahead and do that. Give me 1 second. I'm going to create a new R chunk. Boom. Okay, so I'm going to make this, because I already have the code, but I have to explain it while I do it. So what I'm going to do is I'm going to say, I want test. What's the best way of doing this? All right, I'm going to do a couple things. I'm going to do predict, right? And I'm going to say model A. Remember how we did this last time? Model A, train, comma, test, just like that. So if I were to use this, right, this is going to allow me to predict the actual response variable. What's kind of cool is that it automatically knows which information to use. So if I just run this, boom, these are all my predicted values for profit. This is really neat. What this tells me is that I can start making predictions on multiple values, not just one like we were doing last week, but multiple values for our response variable based on our explanatory variable, right? This is really neat, okay? So the next thing I want to note is that I can actually just I'm going to comment this. I never mentioned how to comment this, but it's Command-Shift-C on Macs and Control-Shift-C. What that means is that if I just run it, it doesn't run. Okay, if I just run it, this goes away. Boom. All right, let me comment that out for a moment. And now I'm going to say I want to find out the true values. Okay, I want to find out the true profit values. Okay, so I just run that. However, I want to see them next to each other. All right, I want to see them next to each other. Boom. I'm going to do this. Call this a data frame. I didn't teach you this either. It's fine. You learn as you go. But we can concatenate or bring both columns together. Okay, bring both vectors together like this. But look at those names. They're disgusting. I don't like those names. So what I'm going to call this predicted values. Actually, I'm going to switch to places. Put that there. Remove this. This is going to be true values. This is the y's. These are our y's. And then here are predicted values. So when I run this, it looks a little bit better. Okay, I have true value, predicted value. I'm going to put an S. What I can now do to be extra, I actually had this in a different way. No, I had it just like this. I can now find my errors. Okay, I can find my errors by doing this. I'm just going to copy and paste this one. All right. I'm going to have to make a little bit of a modification intentionally, but I'm going to call this underscore A. Predicted values under model A. So that I'm going to do that because tomorrow's going to be a little different. So we're going to do this. Okay, so we're going to run this, and now we have all the errors. Okay, which is quite, I would argue, quite neat, right? quite neat. And so we can talk about how well did the model perform regarding our training or regarding our test data, as well as how well the model performed regarding our training data. So you can do both analyses in terms of how well did the model do. This is big. Comment below if you can see how this is big. This is big. I mean, to me it's big, but can you see how this is big? All right, so that is that. We'll do model B and compare both models tomorrow.